Since its arrival around Saturn in July 2004, the Cassini-Huygens mission has opened new vistas on the ringed planet, its myriad of satellites, and the prime focus, Titan, its largest moon. And 2005 has provided much excitement.
We had 14 flybys of satellites, of Saturn satellites, including 8 of Titan. And of course, for us, the highlight of the year is really the Huygens landing on the 14th of January 2005. This was really a great day for us.
Scientists have, over the past year, been analyzing this wealth of data and imagery provided during the probe's descent.
The landscape that Huygens arrived at is a series of low hills with some flat plains in between. Huygens began seeing this landscape as it just began to cross one of the large, bright hills. And as it approached that hill, it saw an area of river channels which run down to a flat plain. It crossed that area of channels and a coast, if you will, to the flat plain, and descended down into a very complicated area of bouldery hills with some flatter areas. It landed on the boundary of a flat area in a rocky or icy plain, I suppose, where material from the hills had run out, been carried perhaps by liquid methane, and was deposited there.
Contrary to expectations, there was haze all the way down to the surface, but transparent enough for good images to be obtained below 40 kilometers. It was a bumpy ride down, with the Hazy instrument discovering a multi-layered atmosphere with evidence of lightning.
Clearly, it means that the atmosphere, the upper atmosphere, is very dynamic, and so is also the bottom atmosphere. I mean, it's a very windy place. I mean, we expected to encounter some winds. We had some winds, and I must say the descent under the parachute was pretty rough.
The in-situ sampling of the atmosphere by the ACP instrument confirmed a rich organic chemistry, with the first analysis of the aerosols.
The core of those aerosols is made of nitrogen and carbon, and this is really very, very interesting, because this is the first time, first of all, that we have really an idea of the composition of those aerosols. And this is really going to tell us a lot about the photochemistry which is producing those aerosols, and also, I mean, what's the composition of the material which is falling on the sky and accumulating on the surface of Titan.
These aerosol layers on the surface could be very thick, as indicated by Cassini ISS camera images of dark patches, relatively recent depositions. Although no rain was detected during Huygens' descent, results from several instruments imply that Titan must periodically have methane showers, with a phase cycle much like that of water on Earth. The landing site was found to have a consistency of damp sand, probably a mixture of ice chips, aerosols, and some liquid, identified by a surge in the level of methane around the warm probe. The surface science package data indicate that the probe penetrated about 10 centimeters into the surface, tipping very slightly to one side, probably by striking one of the many pebbles seen in the very first picture. The wide variety of terrains and landscapes that so resemble those on Earth have been surprising the scientists all this last year.
We see a balance of what appear to be volcanic processes. We see river terrains, fractures. We see basins. We see some highlands. We don't see huge mountains as we see on Earth. That's one thing that's missing. We see very few craters, and that's true for the Earth as well. So other